All right, so this is the notes for Tuesday, constant of proportionality, also known as a constant of variation of a direct variation. Okay, proportional relationships have a constant. So let me zoom on that. Constant or equivalent ratio of y over x. The constant ratio of y over x is called a constant of proportionality. Constant of proportionality. And is represented with the letter K. In proportional relationships, there is a multiplicative relationship between x and y. The equation for proportional equation is y equals kx, where x is multiplied by the constant k to equal y. Multiplied. In non-proportional relationships, there is no constant of proportionality and no multiplicative relationship between x and y. So basically what this is saying is if the slope is multiplicative, then you can call it a constant of proportionality, and k will take the place of m. But this is just a special version of slope is all this is. Okay, so example. Here we have a table. The table shows the amount of money a teenager made for babysitting a certain number of hours. Now, you could find slope by the change in y over the change in x. 24 to 48 is positive 24, and 2 to 4 is positive 2. So delta y, delta x, m is the change in y over the change in x, which is 24 over 2, so m is 12. All right, so that was the old way. But now, since we know, you've been told that this is proportional, it'll have a constant of proportionality, all you have to do is y over x. So k would be 24 over 2. 24 over 2, because k equals y over x. Okay, 24 over 2 is 12. Let's say we did 4 and 48. K would equal 48 divided by 4, y over x, and that's 12. So k is 12. All right, so this only works if it's proportional. Not every linear relationship is proportional, but for today, these are. So just to find the constant of proportionality, we're doing y over x. In this case, y over x, the constant of proportionality will always be the slope. So y equals 12x is the equation. And if you notice, there's no y-intercept. It's 0. That's what makes it proportional, is it's going through the origin. So if a linear relationship goes through the origin, then it is proportional. And you can just find slope by doing y over x. All right, another example. Here we have another table. Again, k is just y over x. We've been told it is proportional, so we can just go y over x, 110 over 2, which is 55. If you want to check it, we can go, there's y, there's x. Y over x would be 165 divided by 3. If you do Tybo for that, you get 55. So k is 55. So the equation would be y equals 55x. Okay? So if you are given a proportional linear relationship or a direct variation, okay, also known as a direct variation, you can just find the slope by doing y over x. Okay. Another example. Now for graphs. So here we have a graph. It's going through the origin. B is 0. If b is 0, then you can just find the slope by doing y over x. So there's my y-axis, there's my x-axis, y over x, k would be 4 over 1, which is 4. 8 over 2. K would be 8 over 2, which is 4. So this point was here, and this point was there. So K is 4. Y equals 4x. Now, if you just wanted to count rise over run, it still works here. So we have a point here, and we have a point here. This would be up 4, 12 to 16 over 1, 3 to 4, 4 over 1. M is rise over run, which is just 4. So you still get the same answer. You can always do change in y over change in x. The y over x, the constant of variation, is only if it is a direct variation. Okay? All right, here's our points. So we're looking for y over x, y-axis, x-axis. This is y, that's x. So k equals y over x, in this case, is 5 over 2. So then our rate of change, or our constant of variation in this case, would be 5 over 2. So y equals 5 over 2x. Very easy, very simple, but it's only if it's a direct variation. That's only if it goes through the origin. Only. And there it is, going through the origin. So it meets that, okay? Now for word problems. Julius buys 10 pieces of gum for $2. He buys another 15 pieces of gum for $3. What is the constant of proportionality? So as you can see, they're telling you what is the constant of proportionality. So they're telling you that it is proportional. So if you want to, you make your table. So X, Y. Remember to always make money Y. Okay. So here we have 2 and 10. Or we can do $3 for 15. Okay. Whichever one you want to do. But regardless, K is going to be Y over X, which is either going to be 2 over 10, or it's going to be 3 over 15. Regardless, it's going to become 1/5 because they'll both reduce. So if I reduce that by 2, reduce that by 2, I get 1/5. Or if I reduce that by 3, reduce that by 3, I get 1/5. So K is 1/5, which means our equation is Y equals 1/5 X. Okay? So, very simple. If it's a direct variation, or if it's proportional, like it said right there, then you can just do Y over X to find your constant of proportionality, which is the rate of change of a direct variation. Okay, so here we have 2 dozen that cost 18, or we have 3 dozen that cost 27. Y, X, Y, X. So K is either going to be 18 over 2, or it's going to be 27 over 3. Regardless, both of those fractions are just 9. So the equation would be Y equals 9x, because K was 9. That means it's $9 a dozen. Okay, $9 a dozen. All right. So that is the end of page 1. Now to page 2. Okay, page 2. So now that we talked about proportional, let's review non-proportional. This is basically what we did all last 2 weeks, getting ready for our last test. Non-proportional relationships do not have a constant ratio of Y over X. Linear relationships can be written in Y equals mx plus b, which we know. there is an additive relationship. That's how we've been finding the change in y over the change in x instead of a multiplicative. Okay. And additive instead of a multiplicative. So m is slope or rate of change, and b is y-intercept. Okay. And then in case you ever need to know, x is the independent variable, where y is the dependent variable. Variables. Okay. All right. So Jessica buys tickets online. She pays $3. The equation is y equals 9x plus 3. Of course, we know that 9 is the slope. All right, that's m. And we know that 3 is b, which is the y-intercept. Okay. So since we can clearly see our table, we can see that b is not 0. In this case, b is 3. There's b. So this is not a direct variation. This does not have a constant of proportionality. We would have to do the change in y over the change in x. The ratio of y equals x is not constant. Instead, the y values are changing by, well, let's see. So to go from 12 to 21, that's plus 9. So they're changing by positive 9. And the x values from 1 to 2, plus 1, is changing by plus 1. The table does not contain 0, 0, but instead it contains 0, 3. 0, 3, that was this point right here, which represents the y-intercept. Okay. Now, over here, this table, the graph does not pass through the origin. It passes right here at 0, 3. This is the y-intercept. So this is an example of a non-proportional. B is not 0. It doesn't go to the origin. Therefore, we just can't do y over x because it wouldn't be the same. We would have to do the change in y over the change in x. In this case, it would be 9 over 1. So here, m is 9, like we said, right here. Okay. And to show you, so if we do 21 divided by 2, that's not 9. 30 divided by 3 is 10. 12 divided by 1 is 12. So you get different numbers from y over x. So that's why it doesn't work for a non-proportional. Okay? All right. So Cheryl pays $10 to park a fare and $2 for each ride. Create a table to represent the situation. Well, she has to pay $10 just to park and then 2 for each. Remember, each means x. So in this case, m is 2, b is 10. So that gives us the point 0, 10. And then if our slope is 2, which is 2 over 1, there's your delta y, there's your delta x. So I'm going to add 2. So 10 plus 2 is 12, plus 2 is 14, plus 2 is 16. And then my change in x, we said was 1. So 0 plus 1 is 1, plus 1 is 2, plus 1 is 3. So there's our table. Okay, that's a fast way to find your table, is you just use the rate of change and apply it. So the rate of change we said was 2. Y-intercept would be 10. So y equals 2x plus 10. It's non-proportional because y-intercept is not 0. Therefore, y over x is not proportional. Okay? So that's the big one. Y-intercept is not 0. And again, if I take my y over x, so let's do this one. Let's do 12 divided by 1. Okay? Let's do that. 12 over 1. So 12 over 1 is 12. But then, if I do 14 over 2, well, 14 over 2 is 7. So those are not the same numbers. So that's why it's not proportional. Okay? All right, one more, and then we're done. A German Shepherd weighs 3 pounds at birth and gains 2 pounds each week. So each means X. So M is 2. And then it started at 3, so there's your B. So B is 3. So my rate of change is 2. My y-intercept is 3. Y equals 2x plus 3. Non-proportional because y-intercept is 3 and not 0. Okay. So I'm going to start at 3. And then if M is 2, well, that's 2 over 1. It's positive, so I'm going to go up and right. So up 2, right 1, puts me here. Up 2, right 1, up 2, right 1. And then there's my line. And you can clearly see it's not proportional because it's not going through the origin. Okay? And y over x would not be constant. What that means is 3 over 1 is 3. But 5 over 2 is not 3. So there you go. So there's the difference between proportional relationships and non-proportional. Okay. Again, if you have any questions, feel free to ask. And make sure you use your notes when doing your assignment. Thank you.